then I lost a lot of weight this spring. Only four months ago I was 122. The 18th February I was 122, and last time I was 105 last month, but that's 2 weeks ago. So 24, and tonight is the 12th, so that's not next week, so that's soon. But I did eat 1.1 kilo of candy and 2 bags of snacks last week, so the next week I have to try not to eat so much food, because I eat all this sweets, this candy. That's nice to read some normal text. I'm reading same time the computer voice is reading. Just use it to help me read it. This is why I'm moving my mouse. I don't need to move my mouse, but I do it because somebody watching this video, they can see my mouse bottom is moving below the text. I don't need to do that, my eyes can follow the text, but I do it because I record on video. Let's continue.
The virtual address space can contain executable code and which cannot. An attempt to execute code from a page tagged no execute will result in a memory access violation, similar to an attempt to write to a read-only page. This should make it more difficult for malicious code to take control of the system via buffer overrun or unchecked buffer attacks. A similar feature has been available on X86 processors since F80286 as an attribute of segment descriptors. However, this works only on an entire segment at a time. Segmented addressing has long been considered an obsolete mode of operation, and all current PC operating systems in effect bypass it, setting all segments to a base address of 0 and, in their 32-bit implementation, a size of 4 GB. AMD was the first X86 family vendor to implement no execute in linear addressing mode. The feature is also available in legacy mode on AMD 64 processors, and recent Intel X86 processors, when PAIs used. Removal of older features. A few system programming features of the X86 architecture were either unused or underused in modern operating systems and are either not available on AMD 64 in long, 64-bit and compatibility mode, or exist only in limited form. These include segmented addressing, although the FS and GS segments are retained in vestigial form for use as extra base pointers to operating system structures. 1170 the task state switch mechanism, and virtual 8086 mode. These features remain fully implemented in legacy mode, allowing these processors to run 32-bit and 16-bit operating systems without modifications. Some instructions that proved to be rarely useful are not supported in 64-bit mode, including saving /restoring of segment registers on the stack, saving /restoring of all registers, pusher /papa, decimal arithmetic, bound and into instructions, and far jumps and calls with immediate operands. Virtual address space details. Canonical form addresses. Canonical address space implementations, diagrams not to scale, current 48-bit implementation, 57-bit implementation, 64-bit implementation. Although virtual address area 64 bits wide in 64-bit mode, current implementations, and chips that are known to be in planning stages, do not allow the entire virtual address space of 264 bytes, 16 EIB, to be used. This would be approximately 4 billion times the size of the virtual address space on 32-bit machines. Most operating systems and applications will not need such a large address space for the foreseeable future, so implementing such wide virtual addresses would simply increase the complexity and cost of address translation with no real benefit. AMD, therefore, decided that, in the first implementations of the architecture, only the least significant 48 bits of a virtual address would actually be used in address translation. Page table lookup. 11. 120. In addition, the AMD specification requires that the most significant 16 bits of any virtual address, bits 48 through 63, must be copies of bit 47, in a manner akin to sign extension. If this requirement is not met, the processor will raise an exception. 11. 131 addresses complying with this rule are referred to as canonical form. 11. 130 canonical form addresses run from 0 through 00007FFFFFFFFFFFF, and from FFFF800000000000 through FFFFFFFFFFFFFF, for a total of 256 TB of usable virtual address space. This is still 65,536 times larger than the virtual 4 GB address space of 32-bit machines. This feature eases later scalability to true 64-bit addressing. Many operating systems, including, but not limited to, the Windows NT family, take the higher addressed half of the address space, named kernel space, for themselves and leave the lower addressed half, user space, for application code, user MODI stacks, heaps, and other data regions. 22. The canonical address design ensures that every AMD 64 compliant implementation has, in effect, two memory halves. The lower half starts at 0000000000000000000 and grows upwards as more virtual address bits become available, while the higher half is docked to the top of the address space and grows downwards. Also, enforcing the canonical form of addresses by checking the unused address bits prevents their use by the operating system intact pointers as flags, privilege markers, etc. As such use could become problematic when the architecture is extended to implement more virtual address bits. The first versions of Windows for X64 did not even use the full 256 TB. They were restricted to just 8 TB of user space and 8 TB of kernel space. 22. Windows did not support the entire 48-bit address space until Windows 8.1, which was released in October 2013. 22. Page table structure. The 64-bit addressing mode, long mode, is a superset of physical address extensions, PAE. Because Office page sizes may be 4 KB, 212 bytes, or 2 MB, 221 bytes. 11. 120 long mode also supports page sizes of 1 GB, 230 bytes. 11. 120 rather than the 3-level page table system used by systems in PAE mode. Systems running in long mode use 4 levels of page table. PAE's page directory pointer table is extended from 4 entries to 512, and an additional page map level 4, PML4, table is added, containing 512 entries in 48-bit implementations. 11. 131 A full mapping hierarchy of 4 KB pages for the whole 48-bit space would take a bit more than 512 GB of memory, about 0.195% of the 256 TB virtual space. Intel has implemented a scheme with a 5-level page table, which allows Intel 64 processors to support a 57-bit virtual address space. 23. Further extensions may allow full 64-bit virtual address space and physical memory by expanding the page table entry size to 128-bit, and Reduce page walks in the 5-level hierarchy by using a larger 64 KB page allocation size that still supports 4 KB page operations for backward compatibility. 24. Operating system limits. The operating system can also limit the virtual address space. Details, where applicable, are given in the Operating System Compatibility and Characteristics section. Physical address space details. Current AMD64 processors support a physical address space of up to 248 bytes of RAM, or 256 TB. 18. However, as of 2020, there were no known X86-64 motherboards that support 256 TB of RAM. 25, 26, 27, 28. The operating system may place additional limits on the amount of RAM that is usable or supported. Details on this point are given in the Operating System Compatibility and Characteristics section of this article. Operating modes. The architecture has two primary modes of operation, long mode and legacy mode. Operating system required type of code being GRUN size, in bits, no off general purpose registers mode is up mode address superins. Default in italics, long mode 64-bit mode 64-bit OS, 64-bit UEFI firmware, or previous two interacting via a 64-bit firmware's UEFI interface 64-bit 648, 16, 32,6416 compatibility mode bootloader or 64-bit OS 32-bit 328, 16, 32816 bit protected mode 168, 16, 328 legacy mode protected mode bootloader, 32-bit OS, 32-bit UEFI firmware, or the latter two interacting via the firmware's UEFI interface 32-bit 328, 16, 32816-bit protected mode OS 16-bit protected mode 168, 1632, M1, 8 virtual 8086 mode 16-bit protected mode or 32-bit O subset or FREL mode 168, 1632, M1, 8 Unreal mode bootloader or real mode OS REL mode 16, 20, 328, 1632, M1, 8 real mode bootloader, real mode OS, or any OS interfacing with a firmware SBIOS interface, 29, REL mode 16, 20, 218, 1632, M1, 8. One note that 16-bit code written for the 80,286 and below does not use 32-bit operand instructions. Code written for the 80,386 and above can use the operand size override prefix, 0x66. Normally this prefix is used by protected and long mode code for the purpose of fusing 16-bit operands, as that code would be running in a code segment with a default operand size of 32 bits. In real mode, the default operand size is 16 bits, so the 0x66 prefix is interpreted differently, changing operand size to 32 bits. State diagram of the X86-64 operating modes. Long mode. Long mode is the architecture's intended primary mode of operation. It is a combination of the processor's native 64-bit mode and a combined 32-bit and 16-bit compatibility mode. It is used by 64-bit operating systems. Under a 64-bit operating system, 64-bit programs run under 64-bit mode and 32-bit and 16-bit protected mode applications that do not need to use either real mode or virtual 8086 mode in order to execute at any time, run under compatibility mode. Real mode programs and programs that use virtual 8086 mode at any time cannot be run in long mode unless those modes are emulated in software. 11. However, Such programs may be started from an operating system running in long mode on processors supporting VTX or AMDV by creating a virtual processor running in the desired mode. Since the basic instruction set is the same, there is almost no performance penalty for executing protected mode x86 code. This is unlike Intel's IA64, where differences in the underlying instruction set mean that running 32-bit code must be done either in emulation of x86, making the process slower, or with a dedicated x86 coprocessor. However, on the X86-64 platform, many x86 applications could benefit from a 64-bit recompile, due to the additional registers in 64-bit code and guaranteed SSE2-based FPU support which a compiler can use for optimization. However, applications that regularly handle integers wider than 32 bits, such as cryptographic algorithms, will need a rewrite of the code handling the huge integers in order to take advantage of the 64-bit registers. Legacy mode. Legacy mode is the mode that the processor is in when it is not in long mode. 11.14 In this mode, the processor acts like an older x86 processor, and only 16-bit and 32-bit code can be executed. Legacy mode allows for a maximum of 32-bit virtual addressing, which limits the virtual address space to 4 GB. 11.14 24. 118 64-bit programs cannot be run from legacy mode. Protected mode. Protected mode is made into a submode of legacy mode. 11.14 It is the submode that 32-bit operating systems and 16-bit protected mode operating systems operate in when running on an x86-64 CPU. 11.14 Real mode. Real mode is the initial mode of operation when the processor is initialized, and is a submode of legacy mode. It is backwards compatible with the original Intel 8086 and Intel 8088 processors. Real mode is primarily used today by operating system bootloaders, which are required by the architecture to configure virtual memory details before transitioning to higher modes. This mode is also used by any operating system that needs to communicate with the system firmware with a traditional BIOS style interface. 29. Intel 64. Intel 64 is Intel's implementation of x86-64, used and implemented in various processors made by Intel. History. Historically, AMD has developed and produced processors with instruction sets patterned after Intel's original designs. But with x86-64, roles were reversed. Intel found itself in the position of adopting the ISA that AMD created as an extension to Intel's own x86 processor line. Intel's project was originally codenamed Yamil, after the Yamil River in Oregon's Willamette Valley. After several years of denying its existence, Intel announced at the February 2004 IDF that the project was indeed underway. Intel's chairman at the time, Craig Barrett, admitted that this was one of their worst-kept secrets. 30.31 Intel's name for this instruction set has changed several times. The name used at the IDF was CT32, presumably for Clackamas Technology, another code name from an Oregon river. Within weeks they began referring to it as IA32E, for IA32 extensions, and in March 2004 unveiled the official name EM64T, Extended Memory 64 Technology. In late 2006 Intel began instead using the name Intel 64 for its implementation, paralleling AMD's use of the name AMD 64. 33 The first processor to implement Intel 64 was the multi-socket processor Xeon, codenamed No-Kona, in June 2004. In contrast, the initial Prescott chips, February 2004, did not enable this feature. Intel subsequently began selling Intel 64-enabled Pentium 4S using the E0 revision of the Prescott core, being sold on the OEM market as the Pentium 4 Model F. The E0 revision also adds Execute Disable, XD, Intel's main 4th NX bit, to Intel 64, and has been included in then